Hello and welcome back to the Introduction to Computer Programming course. And in this session, I'm going to talk about function. So, what is a function? Let me start with an analogy. Suppose you receive a plate of spaghetti, let's say, and then you taste the spaghetti and it does not taste very great. But because it's not you who cook the spaghetti and you can't really see what ingredients goes into the plate, it's rather difficult for you to improve or modify the taste, right? Because you don't really know what goes into the plate, and then you can't also see what's going on inside the plate. So it's really not very easy if you want to say modify the taste of the spaghetti such that it suits your taste, right? Now, it's a different story if you, let's say, cook the spaghetti by yourself and then you separate all the ingredients. Like, this is salt, this is onion, this is garlic, this is the spaghetti, and so on, such that when you taste the final result and it's not so good, you can improve each of those things, right? Like maybe you add some onions and then taste it again, and then you say it's not about the onions, and then you try to cook the spaghetti in a different way, and then you think, okay, this tastes better, but and then you can improve the other things again. So the point is, if you separate all the ingredients and you know clearly um, all the ingredients and how you process all the ingredients, when the final result does not suit your taste, it would be easier for you to modify the final result, right? Just modify separately each ingredients one at a time or a few ingredients at a time and then taste the result again such that you can isolate where you go wrong with the spaghetti. Okay, so that's why I display these two pictures here. The first is the spaghetti that's already served to you in a plate. You can't really see what's going on there. So if you have a program that looks like this, like a very long program, like hundreds or thousands of rows, and everything is just jumbled inside the program, it's hard to debug and modify the errors and improve things. On the other hand, if you have something like this here, um, when your codes is separated into blocks of codes, it would be easy to debug the code, find the error, modify the error, or modify the code such as if you have a new data to process, it will be easier to do that if you have your codes separated into blocks. And that is what a function is about. Okay, so let's start. So let's see what are the formal definitions of a function. So a function is defined as a group of statements known as a code block that exists within a program for the purpose of performing a specific task. So the words that I would like to highlight is the block. So it's a block of code. And another thing is the purpose is performing a specific task. So you know that this block performs this specific task. Okay, so that is a function. It's quite simple actually. Another definition is says functions are reusable pieces of programs. Of course, because you already have a block with a specific function, let's say this block is used to calculate the inverse of a matrix, let's say. Of course, whenever you have a matrix and you need to find the inverse, you just need to reuse that same block again. Okay, so that's why it's called the reusable pieces of program, such that you may use it anywhere else in the program. You just call the name of that block and just reuse it whenever you need that function. Okay, so that is the definition of a function. Now let's go to an example. Suppose during an exam, first the exam program will ask the student's name and student's ID number. And then after that, the program will print out the course name, the exam duration, and the link to submit the answer. After that, the program will show the question 0. And then once question 0 has been displayed for, let's say, several minutes, it will print again the course name, the exam duration, and the link to submit the answer. Maybe such that the student does not forget where to submit the answer. Okay, and then the program will show question 1, and then after several minutes, let's say, the program will print again the course name, the exam duration, and the link to submit the answer. So if I represent this in a flowchart, it will look like this. First, it will read the inputs from the student's name, the student's ID, and then the program will do this three processes, I mean. So printing out the course name, exam duration, and the link to submit the answer. And then it will do the process 0, show the question 0, and then wait several minutes. And then it will again repeat the same three process, printing out the course name, exam duration, and the link to submit the answer. And then do the process 1, which is showing the question 1 and wait several minutes. And then again, do these three processes. So if you look at this flowchart, you can see that actually you can separate this into a block. Instead of repeating these 3 lines over and over again, so it will look better for your code if you just separate these 3 lines into one block. And that is what a function is. So let's see how we're going to do that. So this was our original flowchart in the previous slide. And what we're going to do is that we're going to put these 3 rows into a block, and let's call that block as the print info function. So this becomes our new flowchart, and you can see that these 3 lines in the original flowchart is now represented into just one line. We just need to call function X here, and in this case it is the print info function. Okay, and then in a separate place we need to define that this function, the function X, or in our case it is called the print info function, it does these 3 rows. Okay, so now your main algorithm looks much cleaner, simpler, and easier to follow, because every time it's just call the print info function, show the question, call the print info function, show the question, and finally call the print info function. And in a separate place you say that the print info function does this 3 process. Okay, so that is how we separate some parts of our code into a block, and we call that block as a function. So in general, this is how our algorithm looks like. We start the program, and then we do the other process, and then we call the function. Once we call the function, it will go here, it will start the function, do something within the function, and end. So, and then once the function ends, it goes back to here, and here it says the main algorithm ends as well. Now we have another program. Let's call this exam2 program. The first thing is the same with before, asking the student's name and student's ID. However, the information that this code prints out is different with the previous one. In the first exam program, the information that is printed out is always the same: the course name, the exam duration, and the link to submit the answer. Now here the difference is that the information here is the type of the problem that the student needs to do, and this type of problem depends on the input, which are the student's name and student ID number. Okay, so if we put everything into just one big long code of program, it looks like this. It doesn't really look that much different with our previous program. But then if we would like to change this into moving these repeated rows into a block of function, then we will see the difference in the next slide. Similar to before, we are going to simplify our code by moving these 3 repeated processes into a function, such that they will be performed inside the block of the function. Okay. However, there is something different here with before, is that because the process inside the function needs the information about the student's name and student ID. So that's why instead of just calling the function, we also need to send arguments into the function. Arguments is like a piece of information that we need to pass into the function. Otherwise, inside the function here, they don't know what is the student's name, what is the student's ID number, if we never send the information into that process. Okay, so the difference here is that instead of just calling the function x like before, we also need to pass or send the arguments. In this case, the arguments are the student's name and the student's ID, such that inside this function here, when the function decides which type of problem the student needs to do, it can get the information that the student's name is this, the student's ID number is that. Okay, so the type of problem that this particular student needs to do is this type of problem. Okay, so let me repeat. The difference is here is that when we call the function, we also need to pass the arguments. The arguments are needed such that the function can process whatever task you want the function to do properly, because it has the required information. That's why this function is called the function with arguments. So this is the simplest form of our code. We start the algorithm, there are other processes, and then we call the function x, but at the same time we also send the arguments, such that when we call the function will receive the arguments, and then inside the function it will do something, and then it will use this argument when it does the process inside the function. Okay, once the function ends, it will go back to the main algorithm, and in this case the algorithm ends. Okay, so the main thing here is that we're sending the arguments, and then the function will receive the arguments and will use that arguments to do something inside the function. Okay, although the name is kind of a bit fancy, arguments is actually just the information that such that the function can do whatever it is supposed to do properly. So let's make everything clearer with an exercise. So just like before in the program exam 2, before each question and at the end of the exam, the program must print the type of problem that a student must do. If the student's name starts with a vowel and his or her ID number is an odd number, then the type of the problem is V1. If the student's name starts with a vowel and his or her ID number is an even number, then the type is V2. Similarly, if the student's name does not start with a vowel, his or her ID number is odd, then the type is C1. Otherwise, the type of problem that the student must do is C2. So I would like you to create a flowchart for this type of program that we need to do, and then remember that we are going to create a function for this. Okay, there will be a pause on this video to give you the time to really try creating the flowchart, but I will return after the pause with the answer. Okay. Now here's my flowchart. So first, the program will read the inputs from the user, reads the name and the student ID number. And then it will call the function that I name it as a show type function. And at the same time, when we call the function, we send the information about the student's name and the student's ID number. And we call this as passing the arguments or sending the arguments, okay? Once this is done, the program will print the question 0, and then after showing the question 0 again, we are calling the function the show type, and we are sending the arguments the name and the ID. And then it will print question 1, and then finally before the exam ends, again the program will show the type of the problem that a student must do based on his or her name and his or her student ID number. Your flowchart may look a bit different. For example, if you assume that after printing out the question, then there's another process like waiting for 5 minutes, let's say, to give the time for the students to solve the question, that's okay. The main thing I would like to emphasize here is how you call the function at the beginning of the exam and at the end of the exam and after one question. Okay, so you call the function and then you send the arguments. Now let's see what happens inside the function. Okay, so the main algorithm is really simple. Read the input, show the type of the problem, show the question, show the type of the problem, show the question, show the type of the problem, and it ends. Okay, so that's the big things inside the main program. Now let's go inside the function. So inside the function, what we need to do is first we're checking, does the name of the student starts with a vowel? And then when you have this kind of question, you have two branches. First is the yes branch and the second is the no branch. If yes, then we are going to check again, is the ID of the students is an odd number? So if it's yes, then the type of the problem is V1. We print saying that, hey, you need to do the type V1 for this exam. If it's not, then the student must do the type V2. And then if the name does not start with a vowel, same as before, we check the student's ID number, whether it is an odd number or an even number. Once we have do everything, and then we end this function and then go back to the main program. Okay, so if you check here whether it's an even number, it's also okay. Just be careful with the yes and no. So yes will go to type V2 and no will go to type V1 and so on. It's okay. Here I just use the checking whether the ID is an odd number or not. Okay, so this is our complete flowchart. So you have the main flowchart for the main algorithm, and then you have the flowchart for the show type function itself. Remember that we need to send the name of the student and the ID of the students, because inside the function we need those information to check and to decide which type of problem the student must do in this exam. Now let's go more into the detail. So here inside the function, First, I check does the name of the student starts with a vowel. So how would you know if a string starts with a vowel? And also, when you check the student's ID number, how would you know if a number is an odd number or an even number? Think about these two questions, let's say in the framework of Python programming language. Okay, I will give you the pause in this video to give you the time to think about this, but I will not give you the answer. I will come back after the pause with another exercise. So here's another exercise for you. Create a flowchart of the algorithm to solve this problem. The first thing to do is we are going to ask the user to provide a paragraph. So it's a string. And then we would like to display the following information about this paragraph. First, we are going to print the paragraph, and then we are going to print the length of the string, which means how many characters in that paragraph, print the number of white spaces, and then print the average number of characters in a word, assuming that the words are separated by white spaces. And then once we have displayed all this information, we are going to ask if the user would like to stop or continue. If the user says that he or she would like to stop, then the algorithm ends. Otherwise, we are going to let the user inputs the new paragraph and then displays this information again about the paragraph. Okay, so that's the end for this week, and we are going to talk about function again next week. So see you in the next one, and thank you.